Hello! We finally get to talk about adding and subtracting rational expressions with unlike denominators. So in the last section, we've been kind of preparing for this. We figured out how do you find the least common denominator if you have two rational expressions you're trying to add or subtract. Just kind of practice finding what it is, but in this section we'll actually put that into practice. How do you use the least common denominator that you found to actually make sure you can add these rational expressions? So kind of have an outline here of how to do that. It says, okay, to add or subtract rational expressions with unlike denominators, first thing you're going to do, of course, is you're going to figure out what that LCD is, like we did in the previous section. And then, you know what, just like with regular fractions, like let's look at an example over off to the side here. Let's say you have 2, 15ths, and you're adding 5/6 or something like that. So first thing we do, like it says there, step 1, what's the common denominator? The least common denominator there would be 30? Yeah, 30. Okay, and then now we're on step 2, where you multiply each of those rational expressions or fractions, the numerator and the denominator, by the factors of the least common denominator missing from that expression's denominator. So in other words, like 15, he's made up of what? His building blocks are like 3 times 5. So you want to build him up to 30. So it's like, okay, what is he missing that 30 has? Well, he's missing a 2. If we're only to multiply him by a 2, then he'd be perfect. He'd have that denominator I want. So that's really what this is saying. It's like, what is your denominator missing that the least common denominator has? You're going to multiply by it just to make sure your common denominator is that. And then same thing with the second fraction. 6 times what is 30? Well, he would need a 5 to get there, top and bottom. And then multiply across here. It's 2 times 2, that's 4. 15 times 2 is 30. Then multiplying across on the second one, 5 times 5 is 25. 6 times 5 is 30. And now we add across, like we did in the previous section. Now that they have the same denominator, 4 and 25 make 29. But you don't change the denominator, right? It's 30 still. So it's going to be very similar to that. It's just, of course, the denominators are more complicated. So this kind of just outlines the same steps. Like we said, we find the common denominator, then you multiply each of the rational expressions by basically whatever they're missing that the least common denominator has. And then in step 3, you're going to add or subtract the numerators. Whatever, if it's a plus sign, you add. If it's a minus sign, you subtract. And writing it over the LCD, like we did. You're not going to say, 30 plus 30 is 60. It's still the same common denominator. And then you're going to simplify if possible. Like if this 29 over 30 could reduce, I would try to reduce it. But I know nothing divides into 29 and 30. So that's about it. Okay, let's just try it. Let's try the first example, part A here. We've got 4 over 9t. That looks good. And then 7 over 6t. So looking at those guys, I might off to the side think about what's the least common denominator there. So if you remember, I'm supposed to factor the denominators, but these denominators are so simple, they only have one term each. So really there's no need to factor or anything. I'm just going to think, well, what kind of factors do they both have? Well, they both have a t. That's kind of the only factor or variable they have. And then I also have to include their least common multiple of their coefficients. So between 9 and 6, what's the least common multiple? That would be 18, because that's the smallest number that 19 and 6 can kind of transform into if you wanted to multiply them by something. Alright, so that's the least common denominator. And now for each individual fraction, I'll focus on the left fraction. His current denominator is 9t. So I ask myself, what would I have to multiply that by to get the 18t, So okay, 9t times what is 18t? Well, basically 9 times what is 18? It's 2. So I'm going to multiply the top and the bottom by 2. And I think I'm going to focus on this guy. I'm going to transform it now. 4 times 2, the numerator will give me 8. 9t times 2 in the denominator will give me 18t. Alright, I'll see what happens. Then I'm subtracting whatever happens with the second rational expression. For that guy, it's a 6t as the denominator, but I'd like to see it transform into 18t. 6t times what makes 18t? I guess just 3, because 6 times 3 is 18, and I already have the t there. But remember, whatever you multiply whatever you multiply the denominator by, you have to multiply the numerator by. So this guy will become, in the top, 7 times 3 is 21. On the bottom, 6t times 3 is 18t, which it better be, that's the whole point. And now that they have the same denominator, I can combine them. And of course, the denominator will stay the same, 18t. 8 minus 21 will be, what, negative 13, I think? Is that true? Yeah. And I can't reduce that. If the only way I could maybe reduce that is write, 13 and 18 had something in common, but they don't. So you probably see them, like I said before, you see them write the negative on the side of the fraction. It doesn't really matter. It means the exact same thing. I think just a lot of math people, they think it looks better on the side. So you probably see them write the answer that way. But if you left it the way it was before, that's fine too. Okay, so far so good. We're trying to build up the difficulty level here, kind of one at a time. So let's try part B. We've got 3 over uv squared plus 4 over u to the third v. That sounds complicated, huh? Okay, but let me see. Least common denominator. And this is another one where there's nothing I can really do to factor those denominators. Because they each only have one term. uv squared, that's only one item. u cubed v, that's only one item. So I'm just going to look at what kind of factors do I see. Well, between the denominators I see some u's and I see some v's. That's really all there are. There are no numbers or coefficients. So I think, okay, how many u's do I need? The first denominator only has one u. The second denominator has 3. Remember, I take the larger. The larger of 1 and 3 is 3, so I must need 3. And then for the v's, there are 2 in the first factorization and only 1 in the second. The larger of those, of course, is 2. Okay, so that must be the least common denominator I want. Now I just have to look individually at each fraction's denominator and say, basically, what is that denominator missing that my LCD has? And then I'll multiply by it to make sure it gets that. So first I'll look at the u in the first denominator. I have 1 u, but I'd like to see 3. That means I need 2 more. I'll multiply that guy by u squared. Top and bottom. That way u squared times the u I already have is u to the third like I want. Alright, then how many v's do I want? I want 2. But actually I already have 2 in that denominator. So I don't need to do anything with v's. I'm just going to write, or multiply by u squared. Then the numerator, 3 times u squared is just 3u squared. The denominator, uv squared times u squared. You add the powers of the u and get 3. And the v doesn't change because you haven't multiplied by any v's. That looks good because the denominator is the least common denominator, which was the goal. And then for the second fraction, I look at that guy, and I say, okay, what would I have to multiply that guy by to make his denominator into the common denominator? It already has as many u's as I want, 3 u's, but it only has 1 v and I want it to have 2. So that means I only need to multiply by 1 more v and I'll be there. I only multiply across, top and bottom, multiplied by v. 4 times v, of course, is 4v. U to the third times v, u to the third v times v. It doesn't affect the u to the third, but v times v is v squared. And that's exactly what I wanted it to be. So now I can add these guys together, and like we said before, the denominator will not change. He's going to stay exactly the same. But I'm going to add their numerators. 3u squared plus 4v. Well, they're not like terms, so really the best I can do is write them together in one fraction. And this, if I had any hope of simplifying this or reducing it, I'd have to be able to factor and then reduce. Because this does not factor, I have no hope of reducing it. The numerator has no greatest common factor. You know, nothing comes out of 3u squared and 4v. It looks like it might be the difference of squares because of the u squared, but the v is ruining it, and so is the 3. So that guy really can't be factored. That's as far as we can go. Actually, a lot of these problems cannot be reduced. So keep in mind, let's say about half the problems will be able to reduce, half of them won't. So just like this one, half of the problems, once you add them or subtract them, there's nothing you can do. You might try to factor, but it won't do anything, or it won't work. Alright, let's try part C. This one looks kind of fun. So we got 3c plus d over cd squared. It's kind of a tongue twister, huh? And then c minus d over c squared d. Oh my gosh. Well, think about the least common denominator there. And remember, you're not looking at the numerator right now. Just focus on the denominator. Between the denominators, all I see are some c's and some d's. That's about it. And for the c's, the powers I see are 1 on the first guy and 2 on the second guy. The larger of those is 2, so I want 2. For the d's, the power on the first one is 2. The power on the second one is a 1. The larger of those is 2. My least common denominator must be a c squared and a d squared together. Alright, now I just have to focus on one fraction at a time and say, what would I have to multiply that guy so his denominator is what I want? Now looking at the left denominator, I think he's just missing a c, right? He has 2 d's like you want, But it only has one C and you want 2 of them. So I better give him one more C. Alright, and you know what? When I write that guy out, I'm going to be really careful. The numerator was already 3C plus D. I'm actually multiplying that by C. So be careful. You could distribute if you want to right away, but I'm just going to write it that way for now. Keeping in mind the C is multiplied by both terms. This is the first time where we've seen, in this section anyway, one of the original numerators had more than one term. So far it's only been one term in each. So if you're multiplying to try to get to the LCD, and there's more than one term in the numerator, you better multiply all terms by that guy. And I'll do that next, but the denominator now, CD squared times Z, CD squared times Z, that would give me 2 C's and 2 D's, which is what I wanted, so that's good. As I'm writing these out, I usually check over here to make sure my denominator is what I want it to be. Alright, let's look at the second fraction now. I see his denominator is C squared D, but I want it to be C squared D squared. That means he's missing one D, because he's got the 2 C's, he's missing a D to get to the squared. But of course you have to multiply top and bottom by it. And this is another time where I have 2 terms in the numerator. It's C minus D. So the D I'm multiplying by, better multiply by both of those things, not just one or the other. Alright, and of course you could have at that point all at once distributed the D instead of writing it outside. But I'm always really careful. I like to write it next to it, and then when I get to this stage I'll distribute these guys. This one actually has quite a few steps, huh? So I'll do first this 3C times the C, that'll make 3C squared. The D times the C, it doesn't really matter, you can write DC or CD. Usually you write them in descending or from highest, or earliest in the alphabet to latest in the alphabet. So I'll do C times D. And it has that common denominator, that's good. The second one, now I'm doing C times D, that's CD, or DC, whatever. And then negative D times D will be negative D squared. Okay, that looks good, and it's all over the same denominator. Alright, now we're able to add the numerators. So if you want, you can just add them like terms right away. But I see that the 3C squared in the first numerator has no like term in the second numerator. But the CD and this CD are like terms. One CD plus another CD makes 2 CDs. And then you got the minus D squared, that has no like terms, so he's pretty much on his own there. And it's all over that common denominator, C squared D squared. Okay, so we've added them together. Now I want to see if I can reduce. But in order to reduce, I have to see if either of these factor. The denominator is just one term though, it's C squared D squared, so he has no hope of factoring. Guess I'll see if the numerator can factor. Okay, what kind of a technique would I use? It has no common factor. Like the first 2 terms have a C in common, but not the third. The second and the third have a D in common, but not the first. So okay, there's no common factor. I think if this factored, I'd have to do that, what's it called? The box method, or why do I keep saying that? The X method. So multiply the first times the A times the C. A is 3 and C is negative 1. Let's see, 3 times negative 1 is negative 3. We gotta figure out, are there numbers that multiply to that but add up to the middle guy, 2? I think there are, huh? 3 and negative 1, because 3 times negative 1 would make negative 3. 3 plus negative 1 would make 2. Alright, I'm going to have to take a detour and try to factor this guy. It's 3C squared, and then remember you're going to split the middle term up into something, same variables, and then something, same variables, and the last term stays the same, minus D squared. Alright, where those 2 coefficients are what we found, the 3 and the negative 1. So I'll have a plus 3 and a minus 1. Alright, now I'll kind of break it down the middle and try to factor it. So what can I take out of 3C squared and 3CD? Actually quite a bit, huh? 3C comes out. If I factor 3C out, C plus D is left. If you take 3C out, there's one more C left from this guy. If you take 3C out, the D is left from this guy. And then between the third and the fourth terms, they have a D in common. Whoops. Here we go. But I want to take a negative out as well because there was a negative above it. So okay, if I take, let's see, then I say negative D times what is negative CD? I just need the C. Yeah, that way. Negative D times C is negative CD. The 1 doesn't really matter. 1 times CD is just CD. And then negative d times what is negative d squared? Well, I need a plus d. If I put a minus d, it would be a negative d times a negative d, which is a positive d, but I have a minus here. So I definitely want a plus. That way the negative times the positive will make the negative I want. So I have that c plus d in common. If I take that out, the leftovers are, from the first big term, 3c, and from the second term, minus d. Ugh. Alright, that means we can rewrite this numerator in its factored form like that. 3c squared. Oh, no. Why did I do that? Ah. The c plus d. I just wrote it above. Hello. And then 3c minus d. And then the denominator, we said it's only one term, so it can't really factor. There's not much you can do. And now that I've factored it, you know what I realized? I mean, you do have to factor it to check if it reduces. This doesn't reduce, because the only way you could reduce is if you saw this entire thing, c plus d on the bottom, which I don't. Or if you see this entire thing, 3c minus d on the bottom, which I don't. So all that work factoring just for nothing. But oh well, we never knew, you never know if it's going to reduce or not, so it's a good idea to factor it anyway. And it's good practice, right? There you go. Man, this is tough. It's a lot of work, but let's see. The more of these we practice, the better we'll get at it. Let's try this next one, part D here. So we got a t over t plus 3 and a 1 over t minus 1. That seems kind of simple. So I think, I'm thinking, I think this is the first problem we've seen in this section where there's more than one term in the denominators. Because parts A, B, and C, they all had just one term, one term, one term. But this one, since it's the start of that, I'm going to see if I can factor the denominators. Because part of finding the least common denominator is, if you can factor the denominator, you have to. But in the previous three of these, because there's only one term, I knew it was impossible to factor, and there's nothing I can do. But now that there's more than one term, it could be possible that I can factor this further. Let me look at the first fraction. His denominator is t plus 3. But you know what? That guy can't be factored, right? He's too simple. It's just two terms. Then two terms can only factor into difference of squares and sum of squares. Or sorry, difference of squares, difference of cubes, sum of cubes. But none of those apply. Alright, but it was a valiant effort. And the second guy has a denominator of t minus 1. If I kind of take that down here, same kind of thing. I would try to factor him, but since he has two terms, the only hope he has of factoring is difference of squares, difference of cubes, sum of cubes. But none of those apply. So that must mean I just look at those guys and calculate my LCD. And I guess I'm thinking of t minus 3 as one whole factor and t plus 3 is one whole factor, t minus 1 is one whole factor. Now remember, your least common denominator should have each factor you see. I see a t plus 3, I see a t minus 1. And then you ask yourself, well, how many are there? This guy has one of the t plus 3s. This guy has none. What's larger, 1 or 0? It would be 1. And then for the t minus 1s, this guy, the first one has none. Second guy has 1. The larger of those is 1. So it must be that pretty much I just need one of each. I need a t plus 3 and a t minus 1. So there's my least common denominator. Alright. Now I'm going to bring down the fractions, the original guys, t over t plus 3, and then minus 1 over t minus 1. And looking at each individual fraction, I have to multiply it by whatever it needs to get to have this denominator. So the leftmost one, it has the t plus 3, it's just missing the t minus 1. That means I better multiply top and bottom t minus 1. And it's a good idea to leave it in parentheses, because you're multiplying by, this is the first time where whatever we're multiplying the numerator and denominator by has more than one term. So I need to do that for sure. Let me rewrite that guy downstairs. He is t times t minus 1. And that's over the common denominator t plus 3, t minus 1. And try to resist the urge to cancel these guys. The t minus 1s, if you cancel those, you'll end up with what you started with, right? The t over t plus 3. But we put the t minus 1 there for a reason. There's a point to that guy. So try not to reduce, because it's going to undo the work you did. So I want that guy to be there. All right. Now let's look at the second fraction. He has the t minus 1 in his denominator, but he's missing the t plus 3. So he needs to be multiplied by t plus 3 here. All right, that way his numerator becomes, well, I mean, it's 1 times, I'll just write that, 1 times t plus 3. You could just write t plus 3 if you want, but I left the 1. And then t minus 1 times t plus 1, 3 is their common denominator now. Okay. Now they have the same denominator, so I usually, just like I told you guys, I want to be really careful because it's so easy to make a mistake on these. I'm just going to write them over the same denominator. You know, now they have the same denominator, even though the factors are in a different order. The first one, the 3 comes first, and then the -1. This one has the -1, then the 3, but they're really the same thing. But now that they have the same denominator, I think what I like to do is just keep this guy exactly the same and rewrite it in the numerator. T times t minus 1, just to be careful. And then the other guy I've got -1 times t plus 3, or subtracting, you could say, subtract 1 times t plus 3. I usually do that first because I've noticed a lot of people, they'll distribute wrong and they'll forget to give this minus sign to everyone. They won't go t is negative and 3 is negative. But if you write them in one fraction without distributing yet, and then you distribute now that they're one fraction, it's easier it's easier to not make a mistake. Alright, so now I'm going to distribute as much as I can. The yellow here, t times t is t squared, and then t times -1 is negative t. Now I've got a -1 times t, that's another negative t. -1 times 3 is negative 3. And then in the denominator, I'm keeping that the same. So keep in mind, once your denominator is the common denominator, I would not multiply that out. Don't go t plus 3 times t minus 1 and FOIL it all out. Because in the end, when we simplify this, we're trying to reduce. And when we try to reduce, we're going to have to refactor anyway. There's really no need to multiply the denominator out. I'm just going to leave it exactly the same. It doesn't help you to multiply it out. In fact, it hurts you because later on when you reduce, you're going to have to multiply it out again, factor it out again anyway. Alright, now I notice that in the numerator there are a couple like terms. Negative t and t. Negative t and negative t. So they can combine. I'm going to do, that's t squared. Negative t and negative t make negative 2t. And then the minus 3 over that common denominator. So we've done all the subtracting that we need to. The only last thing would be to see if it reduces. But the only way to see if it reduces, remember, is to factor everything. And again, we kept the denominator factored, which was smart because now we don't have to refactor it again. Denominator is perfect the way it is. But the numerator I can factor, it's a trinomial with leading coefficient 1. So I can just say what multiplies to -3 but adds up to -2. That would be -3 and +1, or vice versa. Wait, is that true? Yeah. And now that I see this, I realize nothing cancels. Son of a gun. Ah, wow. I was all excited, like, because you see the 3's on the top, 3 and 3. Nope. One's positive, one's negative. 1 and 1 on the... Alright, didn't reduce, but what are you going to do? Alright, that one kind of crushed my heart, I think. Because I thought it was going to factor, or, I thought once I factor it, things were going to cancel, but of course not. Okay, calm down, right? Calm down. How about part E? This looks like a wild one. Look at this. 3 over 2p squared minus 2p? What? That's crazy. And then 5 over 2p minus 2? Oh my goodness. Well, I'm trying to, okay, I have to find the common denominator, but like the method in the last section said, to find the common denominator, you have to factor each denominator and then determine what the common denominator is. So I'm going to focus on the left denominator, 2p squared minus 2p. If you factor it, they actually have a common factor of 2p. If you factor 2p out, p minus 1 is left. And that's how this guy factors. Okay. So that'll help me find the least common denominator. The second denominator is 2p minus 2. Okay, if I factor that, really all I can do is take a 2 out. P minus 1 is left. Alright, so you know what? If you don't factor the denominators like we did, you're not going to be able to find the least common denominator. It's essential to factor them. Because now we're able, to find the least common denominator. Let's see. So always remember, least common denominator, you're going to look for all the factors you see between them. On the left one, I see a p, and I see a p minus 1. On the right one, I see kind of the same factor, p minus 1. And looking at their coefficients, 2 and 2, the least common multiple of those is 2. So I'm going to need that. And then I look at each factor, like the p here. What's the most number of times I see p? I only see it once in the first factorization, none in the second. The larger of those is 1. P minus 1, I see it once in the first factorization, once in the second. The larger between 1 and 1 is 1, since they tied. But really, I just need 1, 2, 1p minus 1. There we go. Okay, now I just got to keep in mind I'm going to try to transform both of the original fractions, the 3 over 2p squared minus 2p, and the 5 over 2p minus 2. I'm going to transform them so that they have this denominator. But you know what's a good idea? Once you factor the denominators, like we did, I'm actually going to rewrite those denominators in their factored form. Because if you leave it as unfactored, it's too hard to tell what they're missing or what they have. So I noticed that up here, this is where I factored the first denominator, or the left denominator, all the way. It was 2p times p minus 1. That's going to make it a lot more clear what I'm missing and what I need to multiply by. The second denominator was factored all the way. Here it was 2 times p minus 1. Alright, now it's going to make it way more clear. Now I look at this and say, alright, looking at the first fraction, his denominator is 2p, p minus 1. You know what? That's exactly what the common denominator is, right? It has the 2, it has the p, has the p minus 1. So actually this one you don't need to multiply by anything. It's good. This guy already has the LCD. So there's really nothing you need to do to it. I'm just going to leave it exactly as it is. Maybe I'll just even rewrite it below, just to remind myself why I didn't do anything to it. 3 over 2p times p minus 1. Yeah. Hopefully that makes sense, because you notice his denominator is exactly what I want it to be. So there's no need to multiply it by anything. I don't need to do anything to it. The second one, though, I might have to do something to. If I look at the denominator in the second one, it's 2 times p minus 1. It's missing this p here from the LCD, so that's really all I need to do is multiply top and bottom by p. Alright, that's not too bad, because the numerator only had a 5. So it's 5 times p, that's 5p over. And now the denominator, 2 times p minus 1 times p, you can write it so it looks exactly like the other denominator if you want. Put the p in between the 2 and the parentheses. Alright. Now I can take their numerators and add them. 3 plus 5p. They're not like terms, so there's not really anything I can do there. And write it over that denominator. And this is where, okay, I've added them together, but maybe I want to see if I can reduce. Let's see, can I reduce this? If I could reduce this, well, the denominator is already factored, so he's as good as he's going to look. But the numerator can't factor, right? There's not really anything I can do with that. There's nothing in common. Yeah, it doesn't factor because there's nothing in common between 3 and 5p. It's not the difference of squares, sum of cubes, difference of cubes. So I think that's going to be our answer, but I might write descending order of powers because it looks better. 5p plus 3, and then the denominator, keep it the same. There we go. Actually, that one seemed a lot easier than the previous one, huh? I thought, but oh well. Alright. Let's look at this next one here. X over x squared plus 9x plus 20 minus 4 over x squared plus 7x plus 12. Okay. This one, oh my gosh, it's so essential to factor these denominators. If you don't factor these, look at this guy. X squared plus 9x plus 20, x squared plus 7x plus 12. Oh my gosh. What the heck is the least common denominator between those guys? It's basically impossible to figure out unless we factor both denominators. I'll focus on the left one first. It doesn't really matter, but I always focus on the left one. If I grab his denominator, x squared plus 9x plus 20, that factors into x plus 5x plus 4, or vice versa. In the second fraction, his denominator is x squared plus 7x plus 12. He factors into x plus 3x plus 4, or the other way around. Okay, now looking at those two denominators, I think I can figure out the least common denominator. So between the least common denominator, I have to look at the factorizations and see what kind of factors do I see. I'm trying to be greedy here. I see an x plus 5, I see an x plus 4, and I see an x plus 3. I need at least one of each of those. I'm going to see if I need more of any of them. For x plus 5, I see one of them on the left, none on the right. That means the larger is 1. For the x plus 4, I see 1 on the left and 1 on the right. So the larger of 1 and 1 is 1. They tied. And x plus 3, I see none on the left and 1 on the right. The larger is 1. So okay, I guess really the only thing we need is one of each of these guys. An x plus 5, an x plus 4, and an x plus 3. Okay, now I want to take the original fractions. I'm going to rewrite them, but I'm going to rewrite them with their denominators are factored. Because, I mean, imagine, I'm going to write it the wrong way. I'm going to write it the original way it was. X squared plus 9x plus 20. What you're supposed to do now is look at the denominator you have, say, alright, what's this guy missing that this guy has? How am I supposed to tell when it's not factored? I have no idea what I have or what I don't. So you really have to write it in factored form. Once you determine the LCD, make sure you write your denominators in factored form. Because remember, this guy's denominator was x plus 5, x plus 4. Well, now it's way more clear what he's missing, right? If I look at that denominator versus the common denominator, he's pretty much just missing that x plus 3. So I'll go top and bottom x plus 3 for both of them. Alright, then between the two fractions there was a minus sign. I can't forget that. The second fraction, or the fraction on the right, had a 4 over... Now I'm going to write that guy in factored form as well. It was here, x plus 3 times x plus 4. Now what's he missing from the least common denominator? You know what? I should keep these the same color now. The left fraction has been red stuff so far. The right fraction should be green stuff. Alright, so the right fraction has an x plus 3 and an x plus 4. What it's missing from the LCD is the x plus 5 that's in the front. So he needs x plus 5 top and bottom. Alright. And usually at this point, I actually skip this, or I kind of skip a step in a way. Notice now that I've given this guy an x plus 4, and I've given this guy an x plus 5, they have the same denominator now. So I'm just going to write it as one big fraction over that denominator. And it doesn't matter what order these factors are in. I'm just kind of copying the, I'm just copying the left fraction's denominator. But notice the right fraction's denominator has the same, the same stuff. Yeah, it has the same stuff, it's just in a different order. So really, the denominators are the same, they're just in whatever order you want, as long as you have the factors there somewhere. And then I'm going to be careful, like I said before, write the first numerator exactly as it is. I'm not going to distribute yet. Really what I'm worried about is, it's easy to forget that this minus sign here is meant for that entire term. So it's minus 4 times x plus 5 from the second numerator. So hopefully that makes sense. I'm just leaving the first numerator as is, rewriting it. And the second numerator is minus 4 times x plus 5. And now I'm going to distribute, because I think if I distributed before, I might not be careful enough. So let me distribute this x times 3, and then think of this as negative 4 times x, and then negative 4 times 5. What do we get there? Let's see. X times x squared. X times 3, 3x. And then we have negative 4 times x, that's negative 4x. Negative 4 times 5 is negative 20. And then all over that common denominator. And definitely just, like we've said before, don't bother multiplying the denominator out. In the end, you're going to want to see if this thing reduces, and you're going to have to factor the denominator anyway. There's really nothing helpful about multiplying that denominator out. It just complicates it. And the numerator has a couple like terms in the middle. 3x minus 4x makes negative x. And the denominator is just kind of along for the ride. Alright, now we've kind of simplified it as much as we can, but I would like to see if it reduces. So it's all gonna kind of come from, does the numerator factor or not? And I think this guy does factor. That's a trinomial with leading coefficient 1. So if it does factor, it should be that easy factoring method. An x and an x, the denominator stays the same. But what I'm looking for in the numerator is, what are those numbers that multiply to negative 20 but add up to negative 1? That'd be negative 5 and positive 4. Because negative 5 times positive 4 is negative 20. Negative 5 plus positive 4 is negative 1. All that work did pay off because we have one factor that cancels. But the x minus 5 on top does not cancel. The x plus 5 on the bottom doesn't, and neither does the x plus 3 on the bottom. So there it is. Oh my gosh, that was a lot of work, you guys. Whew. So be careful. There's a lot of steps to these, and it's very delicate. You do one little thing wrong, you forget a negative, or you multiply wrong, or your LCD's wrong. It's all bad. Just the more steps to a problem there are, the more likely you are to make a mistake. So be careful. Write neatly. Don't worry about taking too long to do these problems. Take your time. Don't worry about taking too many steps either. It's better the more steps you write, because you're less likely to make a mistake. Alright, we got two more here, and these are kind of like sort of the challenge problems, because you notice in part H and part I, we have three fractions being added or subtracted. So we got to consider the least common denominator of all three denominators. So let me look at the first fraction in part H. I've got the denominator there, r squared minus s squared. And let's see if that guy factors. And that actually does factor, because that's a difference of squares. That's r minus s, r plus s. So, okay, there's one denominator. The second one is a r plus s. That guy's not going to factor. He's kind of his own factor. You can think of him. Because it has two terms. There are no like terms. The only hope he has of simplifying, of factoring, is if he's a difference of squares, sum of cubes, or difference of cubes. But he's none of those things. Same thing with the last guy. His denominator, r minus s. Nothing you can really do with that. It doesn't factor. So I'm looking at these three different denominators and trying to determine what the common denominator is. So I know my least common denominator should contain any factor I see. There are actually kind of only two factors here, r minus s and r plus s. And I think the most number of times either of them occur is once, because r plus s is only once in the first one, none in the second one, and 1 in the third one. The highest power I see is a 1. For r plus s, I see one of them in the first, 1 in the second, and none in the third. The largest power I see is still a 1. So the LCD is r minus s, r plus s. Exactly just one of each. Okay, let me try to now rewrite the original fractions so that the denominators are factored. So we did factor the first denominator. It was r minus s, r plus s. That's going to make the problem easier. We decided the second fraction's denominator did not factor, so I'll just leave it as is. Same thing with the third one. He doesn't factor r minus s, so I'll just leave him as is. And then for each individual one, I'm going to multiply it by whatever it needs to get the least common denominator. So I look at the leftmost denominator, r minus s, r plus s, and I say, well, what is it missing from the LCD? It's missing nothing, really. It's exactly what I want. So because this is the LCD, there's nothing I need to do to it. I'm just going to copy it directly down. Don't do anything to it. It's 2r over r minus s, r plus s. It's perfect the way it is. Plus, okay. How about the second fraction? It has a denominator right now of r plus s. So I look at the least common denominator and I say, what is it missing? Well, it has the r plus s, the second factor. It's missing the r minus s, so I need to multiply top and bottom by r minus s. Let me rewrite that guy down there. I mean, it's 1 times r minus s. That's really just r minus s. So if I wanted to, I don't really need the 1. You could put the 1 and be careful later, but I just know that 1 times anything is that thing, so there's no need to put 1 times r minus s. Alright, finally, the last denominator is r minus s. And if I look at the least common denominator, it looks like it has the first factor, but not the second factor, and needs that r plus s, top and bottom. Okay, so that one will become, this is kind of similar, I just got to keep in mind there's a minus there. It's subtracting fraction. I mean, it's 1 times r minus s, 1 times r plus s. I'm just going to write r plus s. And then the denominators, same thing as the other ones. Alright, looking at all three of these fractions, and now I'll have the same denominator, r minus s, r plus s. Even though the middle guy's got it in the opposite order, it's still the same thing. Alright, so I'm going to be careful here. The first numerator is 2r plus the second numerator, I'm going to write in parentheses just to be safe. And then you're subtracting this minus sign here, the third numerator, r plus s. And I'm putting that in parentheses because I'm afraid that I might forget that this minus sign here is meant for this entire numerator. So I would not put r minus r plus s like that, because that minus looks like it's only for the r, but it's actually meant for both, because you have to distribute it. It's really not a bad idea, once you combine 2 or 3 fractions into one, to write their numerators in parentheses, so that you remember that the plus or minus sign, whatever the case may be, the plus or minus sign is meant for that entire numerator. So okay, I'm going to rewrite this guy. I'm going to remove the parentheses by distributing anything that needs to be distributed. The 2r from the first fraction is fine. The r minus s from the second fraction, I mean, you can distribute a plus, but that's not going to do anything. It's just plus r minus s. But this minus sign here will do something. A negative on a r and a negative on a s will make them both negative. And then over common denominator, r minus s, r plus s. We're almost done. Now we just have to combine like terms. In the numerator, I noticed that the r's cancel here. R minus r is nothing. So there's really only that 2r is the only r left in the numerator. The s's I was thinking might cancel, but they don't. Negative s and negative s make negative 2s. And the denominator is exactly the same. R minus s, r plus s. Whew! So we've added our rational expressions, or our fractions, if you want to think of them as fractions. But now we want to see if we can reduce. And really all we have to do to see if we can reduce is try to factor the numerator, because the denominator is already factored. So I'll see what happens with the numerator. The denominator is going to stay the same. I'm just kind of hoping once I factor the numerator, maybe I'll see one of these factors in the denominator up in the numerator as well. And factoring in the numerator, all I can really do is take a 2 out, because those two terms have a 2 in common. If I factor a 2 out, r is left. And if I factor a 2 out of the second term, negative s is left. And look at that. Isn't that the most satisfying thing you ever saw in your life? R minus s is cancel! Yay! So all that's left on the top is 2, and on the bottom, r plus s. Wow, that's the type of problem where I can't believe how nice it ended up, how ugly it started. Where was that guy? He was pretty bad, right? I thought he was. Wait, did we just skip a problem? Oh my gosh, I'm sorry. I skipped one, you guys. Come on. Ah, well, you know, what are you going to do? As long as we get them all done eventually, right? Sorry. Let's go. Okay, part G here. Looking at that guy. We got 2 fractions, so this almost seems like a cakewalk compared to the last one, huh? His denominator is y minus 3. That doesn't factor. That's as simple as it gets. Let me look at the second fraction. It's 9 times y, or 3 minus y. Or sorry, 9 over 3 minus y. So his denominator is 3 minus y. Huh. Now you know what I'll do though is, I notice that those terms are not in the right order, right? It's negative y plus 3. It should always be the leading term first. And then I notice, okay, can I factor anything here? Well, y and 3 have nothing in common, but they did say you should take a negative out if the leading term is negative, right? The highest powered term is y, and he's negative, so I'm going to take a negative 1 out. What happens if I take a negative 1 out? Negative 1 times what is negative y? Well, that'd be y. Negative 1 times what is negative 3? I'm sorry, negative 1 times what is positive 3? It'd have to be a negative 3. Because that way negative 1 times negative 3 is positive 3. And it's a good thing we did it that way, because now you look at these two denominators, they have a factor in common, y minus 3. So interesting. Now, if I want to calculate my least common denominator, I look at these two denominators and I say, all right, what kind of factors do I see? I see a y minus 3, and the only thing else I see is a negative 1. So that must be my least common denominator, because I only see one negative 1. I don't need a power on negative 1. And the y minus 3s, they both only occur once. So the largest number of times I see that is once. So okay, there's my LCD, negative 1 times y minus 3. Okay, that was tricky, but once I thought about write your terms in descending order of powers, then I noticed, oh wait, the leading term is negative. Maybe I'll take the negative out. So it kind of worked out that way once I remembered what I was supposed to do, writing things in descending order of powers. So I got y squared over y minus 3. Remember that the first fraction's denominator did not factor, so I'll just leave it. But the second fraction's denominator, remember we factored a negative 1 out, so I'll do that. Negative 1 comes out, y minus 3 is left. Okay. Now looking at each individual fraction, let's say the first one, I look at his denominator, y minus 3. What's he missing that the least common denominator has? I guess it's missing the negative 1, because my denominator has the y minus 3, just does not have the negative 1. So I'll multiply that guy there. Negative 1 on top, negative 1 on the bottom. So on the top, it's y squared times negative 1. That's really just negative y squared. On the bottom, remember they said you just want to keep it factored, so I'm going to maybe write the negative 1 in the front, and then the y minus 3. Although you could put the 1 on the side. Y minus 3 and then negative 1 on the right. Doesn't matter. I was kind of just trying to make it look more like his friend on the right side. Alright, if I look at the second fraction, his denominator, it's negative 1 times y minus 3. So I'd say, okay, what does the LCD have that he's missing? Actually, it is the LCD, right? This common denominator, that is the LCD. There's really nothing I need to do to that one. I'm just going to leave it as is. Okay, it's plus 9 over negative 1 times y minus 3. There's nothing really that I need to do to it. Alright, now what? Now, they have the same denominator, so we can combine their numerators. It's negative y squared plus 9 over negative 1 times y minus 3. Alright, we're getting there. Now, we've kind of done all we can, except I want to see if it reduces. And the denominator is already factored. Now I just have to see if the numerator factors. Well, the numerator, I notice, again, this is another time where the leading coefficient is -1. Since the leading term has a negative, I think I'm going to factor a negative out first. Let's see, so if I factor a -1 out, what's left over? -1 times what is negative y squared? That'd be positive y squared. -1 times what is positive 9? That'd be -9. Okay, and I'm keeping the denominator the same, because it's already factored. And then I notice what's in the parentheses, now that I factored the -1 out, this guy's a difference of squares. So I can say, okay, that's y minus 3, y plus 3. And the denominator I'm keeping the same. And you know what? You notice a lot of things cancel actually here. Now that I've factored it all the way, these y minus 3's cancel, but also the -1s in the front cancel. So all that's left in the numerator is the y plus 3. And the denominator, since everything canceled, you could say a 1's left. But we know a fraction with the denominator of 1 is just, you can get rid of the denominator. It's just really like a whole number. It'll be y plus 3. Whew! That one was, it seemed difficult, but I feel like the one we just did was more difficult. It's probably because we jumped the gun and did a further in problem in the section than we were supposed to. Whew! So these problems take forever, and that's why this video is really long. I'm sorry about that. But now we're on the last one, you guys. Hopefully that makes you feel better. Part I. This is as bad as they can get right here. So I think if you can understand this one, you can do any of them. Alright, let's try this guy. I want to first see what the least common denominator is, but I'm going to have to factor each denominator first. Looking at the very left guy, this denominator is a trinomial with leading coefficient 1, so this should be the kind of easy factoring method. What multiplies to -2 but adds up to +1 will be +2, -1, or the other way around. So there's his factorization. Then we've got this guy, 5 over x squared minus x minus 6. He's got a similar factorization because it's a trinomial leading coefficient 1. This time I'm looking for what multiplies to -6 and adds to -1. It'd be -3, +2, or the other way around, +2, -3. Whew! And the third guy, 2 over x squared minus 4x plus 3. That one's also a trinomial leading coefficient 1. So I just need to figure out what are the numbers that multiply to 3 but add up to -4. That would be -3, -1, or vice versa. Since -1 times -3 is 3, -1 plus -3 is -4. Whew! Alright, those are the three factorizations. Now I'm going to look at those three guys and see what that LCD is. Okay, LCD, it should contain every factor I see. Just from left to right, I'm going to grab x plus 2, I'm going to grab x minus 1, I'm going to grab x minus 3. When I get here, I realize I already have x plus 2, I already have x minus 3, I already have x minus 1. And I think for each of these, the most number of times you see these is once, because everybody has a power of 1. I don't see any powers larger than 1 here, so I really only need 1 of each. Whew, alright. 1 of each of those 3 factors is my least common denominator. Now I'm going to rewrite the 3 fractions above, but I'm going to write their denominators in factored form, like we said. So this guy's denominator is now x plus 2, x minus 1, just kind of copying when I factored it above. And then the second fraction was subtracting. His numerator was a 5. His factored form was x minus 3, x plus 2. The third fraction you're adding, and it had a 2 in the numerator, but its denominator we factored into x minus 3, x minus 1. Whew! Alright, so now for each individual fraction, I just have to think, what is its denominator missing that the LCD has? Looking at the left one, it has an x plus 2, it has an x minus 1, but it's missing this x minus 3, huh? So I need to give this guy x minus 3 numerator and denominator. And maybe I'll rewrite that guy down there. It's 4 times x minus 3. And you know what? This is where, just to give you a hint as to how I do these, I know that once I multiply each of these by what they need, they're all going to have that least common denominator. So I usually just at this point write them all over that least common denominator, just trusting that I'm going to multiply by the right thing. Okay, I just write their numerator. So now the second fraction has the x minus 3 and the x plus 2 in his denominator. He's missing this x minus 1. So he must need that numerator and denominator, x minus 1, x minus 1. Okay. In his numerator it has a minus sign, and now it's a 5 times x plus 1. Or sorry, why is it plus? Where did I get the plus from? Losing my mind over here. X minus 1, hello. Alright, maybe just a color code. The first numerator was 4 times x minus 3. Alright, the last guy, or the third guy on the right, he has a denominator with x minus 3, x minus 1. So he must be missing the x plus 2 from the LCD. I'll multiply top and bottom by that, x plus 2, x plus 2. And so he had a plus sign, that'll come down, plus, and now his numerator is 2 times x plus 2. There we go. And yeah, I could write those as 3 separate fractions, but the next step would be put them together anyway. Now that they have the same denominator, I'm just going to write it. This is usually, just so you know, this is how I do it. When I go about these problems, I don't do a middle step there. I just write it all over the same denominator. And now we're able to distribute. I'm going to distribute this 4 in here, distribute this negative 5 in here, and distribute this 2 in here, being really careful. Because if you got this far without any mistakes, the hard part, then you don't want to make any mistakes from here, because this is the kind of smooth sailing part. Whew, if I distribute that 4 times x is 4x, 4 times negative 3 is negative 12. Okay, so we got that, and then I have negative 5 times x, that'll make negative 5x. Negative 5 times negative 1 will make positive 5. And then 2 times x, that'll be plus 2x. 2 times 2 will be plus 4. And again, don't try to multiply out the denominator. It's not going to help. It's actually going to hurt, because we're going to try to see if we can factor later to reduce. Alright, now the numerator has a lot of like terms. What do we have here? 4x minus 5x plus 2x. Let's see, 4x minus 5x, that's negative x. Negative x plus 2x is just x. I'm just going to write the denominator now. I know it's not going to change. About the constant terms. Where are my constant terms? 12 plus 5 is 17. Plus 4 is 21. Whew. There it is, plus 21. And I would try to factor that. You know, I want to see if it reduces. Reduce, question mark? Well, it'll all depend on if this guy factors. But x plus 21, that doesn't factor. That's too simple. It only has 2 terms, so it'd have to be difference of squares, difference of cubes, sum of cubes. But neither x nor 21 is a square or a cube, so there's no way that's going to happen. Whew! That was a good one, you guys. This is really, really tedious and difficult stuff. And if you find yourself, if you keep getting these problems wrong, and probably write, like I said, write more clearly, write larger, and try to show more steps maybe. Maybe you're skipping too many steps and you're not writing enough. That's usually what it is. If you skip a step, you might, I think usually it's distributing a negative, like up here at this point, we had negative 5 times that. Sometimes people forget to put parentheses around x minus 1, and they'll forget, or they won't give the negative to everything, and just one term with the wrong sign will screw up these problems, and it's really frustrating. But if you're really careful and you write all your steps out, it should be okay. Okay, well, thanks for listening. Sorry if that was kind of overwhelming, so if you want to go off and kind of just stare at the wall for a while, sometimes I have to do that. My brain is kind of on overload. Just stare at the wall and don't think about anything. Or if you have to think about something, think about puppies and kitties and bunnies and cute things like that. And then when you're all done with that, you can come back and we'll have more fun in the next section. Believe it or not, it gets more fun. Can you believe that? It's hard to believe, am I right? Come on. This is already as fun as I thought I could possibly have. It's like what if you go to Disneyland as a little kid and they say, well, there's more fun. You're like, what? How is there more fun than Disneyland? That's crazy talk. But believe it or not, there is. So, all right. Have a good day. I'll see you in the next video. Bye.